Hello YouTubers, hello SpaceX fans. Welcome back, Dredis here. I'm surprised as to how many people checked out my last video where I was showing off some, you know, some cool idea. One of the things that came up in my feeds was an interesting video, and I just want to show it real quick.
NASA Glenn engineers Chris Cantos and Tim Smith can now call themselves inventors, too. They are the minds behind NASA Glenn's breakthrough material, a super alloy developed for extreme conditions of air and spaceflight. It's called GRX 810.
In a rocket engine, you can go from 0 to 1,000 or 2,000 degrees within a couple of seconds. So we need a material that's robust and reusable. And that's one of the big selling points for GRX 810 is it can stand many reuses.
It all begins with a metal powder inside a 3D printer. A laser melts the extremely thin layers together. Slowly, a part is formed. The true test is heat. Temperatures that would cause other alloys to fail is no problem for GRX 810, making it ideal for stronger, more durable parts in rockets and airplane engines. The secret? The metal powder is coated with a ceramic before it's printed. But this happens at a nanoscale level. Particles so small they use sound waves to get the correct mixture.
So that video ended up coming into my feed soon after I had gone and posted this video on YouTube about 3D printing the exterior of the rocket, or using like a 3D placing device with a 3D printer mixed in. Now, I don't know if that particular application is going to work because they said that it was like a metal and a ceramic that's kind of molecularly together. So the metal will probably end up being the weaker point. And so I'm not really sure how that would work in this respect. And one thing's for sure, speed is a factor when it comes to reuse and being able to do maintenance on these sorts of tiles. Thanks for commenting. And someone had mentioned that it looks like the rocket would vibrate while flying, and so I only posted with these supports, but you can like put just tons of supports all the way through this thing. So that I just didn't want to clutter it with supports, like showing where all the support points would be. But yeah, you would end up posting like little pins and wires. The concept would be kind of like a bicycle, like when you on your bicycle rim. So like this particular rim right here. So imagine the tank is in here, and then you just have like these wires all woven all throughout the interior of the vehicle, just holding the tanks and creating, like a support structure that goes all the way around this here and ends up being like a double layered support wire structure. So I didn't include that. One of the things that I was curious about, and I have no idea if this is possible or not, but when I was watching the video, right, I was like, man, it'd be so awesome if, let's say, we had, this here, and let's say this is the methane tank, and then this could be a piston that like pushes the methane tank and empties it, right? And then by the time you're in space, you only have like a little bit of methane left for the final burn. That would save the helium that you would need in order to go and pressurize the tank. The idea is that you'd use it like a big piston, right? And also, Elon had mentioned that the rocket wants to come in butt end first because that's where all the weight is. And I was thinking that once all these are out of here, this whole thing. So if I took the payload, right, and I took the payload out, or at least the majority of it, right, and then move this up. You could maybe position the rocket bells to be further in, and then this whole thing could slide. So this whole thing could actually, if it was acting like a piston, right? So once it gets up there, then we leave that one there, and then it's flying in, and then this could actually go up and down inside the chamber and allow the unit to use this as weight or balance or counterbalance, right? So then this could be up in the body, and then that would end up pivoting the whole rocket, move the rockets further up into the chamber in order to allow it, like, to move the center of mass up and kind of try to get it to tip over and come in on the Earth's in this angle. So this is all speculative, but I'm going to show you the next iteration of this design, and we're going to talk about the Starship and the real question, which is this actually a starship? When it's in space, it goes sideways, right? So here's the payload. So this thing here comes out, right, to about there, and then the payload comes up and out of the machine. So this is a 5x5x15. Now, you're in orbit, which means that this here is not necessarily, this is a construction piece. Okay, so another vehicle, like a little vehicle, will come along, grab this, and then we would start creating something with it, right? Now, this may seem like just a brick, right? Then this thing goes back in, goes back down to Earth, right? And it's gone. But now we have this brick. So this brick is a 5x5x15. Now what are we going to make with this brick? Well, this is a module, right? So I'm going to go and make a 3x3. Then I'm going to make a 9 square module. Okay. Then I'm going to take the 9 square module and I'm going to build it 15 times. Okay. And this is what's called Starship. Now, it doesn't quite look like Starship just yet. And this is a Starship, which I know it looks like just a bunch of boxes. 519 boxes to be exact. So when Elon said he wants to see 1,000 starships go to Mars, well, here's 519 of them. At least the cargo's worth, the ship, and then all the stuff that's in it. Now, you'd probably have a bunch of starships stuck to the outside. And you're probably wondering what this shape is, because it's an odd shape. But if you have a close eye, you can see. And then you can make this. So you end up with about 519 pieces of cargo or habitat delivered into orbit. And then you create a ship like this. So this way you can have gravity. So it's kind of like if you took 2 towers and you stuck them together and then you rotated them. So at the far end, it's going to be like around Mars gravity. That's the beauty of this, is that you can go and create arrays of compartments and mass produce all the pieces just by repeat, right? And then the front would end up being basically cargo. And so you've got, you know, your thrusters as well as thrusters, plus then fuel and cargo, and then you would have a bunch of ships. Let's throw another bunch. In fact, here you could just hook on the starships here, and then they can power the ship, right? And this is what I call a starship. Right? And this is completely doable with the current technology. Head to Mars, park in orbit, and then start delivering all your stuff down to the planet. All right, well, there you go. There's the ship. Now, if you look at the back here, you've got the starships mounted in here. You could probably place them on these sides as well, so you'd end up with like 8 of them on either side. Oh, yeah, and then these are probably facing the wrong direction. So if these were facing the other direction, then the whole ship could like speed up, go to Mars, and then, I don't know, wouldn't necessarily have to turn around in order to slow down, right? And then if you look at it, like if you're sitting there kind of orbiting the planet like this, you know, it's pretty easy to just stay in Leo around Mars and around Earth and just transfer between the two every 2 years. And this is meant to be kind of like an aircraft carrier amount of people. So like 5,000 people, I guess. Or at least that's the idea. Something that's like a decent sized crew. So yeah, there you go. That's my starship design. And this is an actual starship, right? Like and subscribe and come back for more SpaceX futurist video game content. Where would I have my room? Probably on the end of one of these two. Although it might be comfortable to sleep up here where there's less gravity.